right, so welcome everyone for High Performance Computing, Advanced Scientific Computing. We have our final lecture today, final lecture 16, which is an epilogue to the course, and it is such a little bit different than the course hours we had together before with all of lecture content or the industry project you were working on. So today we want to look a little bit on high performance computing, basically as a bigger picture, connecting it with many different aspects that you will learn in your future life when you maybe go to companies. So which are relevant aspects? Where's the European Commission going with AI factories, with new interesting elements? I incorporated this a little bit. And then also thinking a little bit about what we learned, thinking about the job descriptions and so on. Where do you find materials of potentially finding jobs and so on. So it's a sort of informal final lecture I do just to give you, let's say, perspectives of these different levels that I think very important in general. You always have to think about when you go to the field of the job workforce or even in science and engineering, you have these different levels on mindset, skill set, tool set. And this is something also what is maybe interesting to look at when you have now a full course where we basically have to put this a bit in context, because a course is a little tiny thing of a huge community, of huge technology. And with this, we have to be a bit open-minded, as the name firstly also suggests. So we'll go a little bit into job offerings in the market, also thinking about all the buzzwords that you learned in CFD, but also in generally AI, deep learning, machine learning, GPUs and so on. So where do we find this in job description? So we go to LinkedIn Jobs and also Glassdoor. I can recommend you to find jobs. And there also be open-minded maybe to more academic ideas. So we have also master and bachelor theses around. I will talk about this also in a minute. Then a little bit we go back to the skill set. So you have now different techniques, paradigms really that stand the test of time, but also, let's say, aspects of theory. So we put that all into a perspective to give you some indicators which probably will remain in the next 10 years versus some of the more hype topics maybe that are just, shortly around. And then when we talk about the tool set, many of that you have learned. Again, machine learning, deep learning needs HPC. I think by now you know that. And also the European Commission is appreciating this a lot with AI factories and the AI continent. If you are in social media, you have probably seen several posts around that. We are part of that community. And I will also show you a little bit, what that means. There are related topics which would require another university lecture, like quantum computing, neural networks on the chip, which we call more or less neuromorphic chips and neuromorphic computing. These are all elements which shape our future. So we have already publications in quantum computing, but we're not there yet of having, unfortunately, a complete course. I think, Herman, you had a quantum cryptography course at least, right? So the first steps to go towards this future, but there we can expect probably much more in the next couple of years. So again, when we think about the outline, I really want to bring across the HPC from a complete different perspective. Here and there discuss some of the elements that we maybe not have in the course because they are sort of not technical, but very important to understand. Further readings and also the HPC community. I will highlight some of the aspects which are related to your industry project. So if you go to industry, people may ask, why HPC? So we have a couple of success stories in the EuroCC network I will show you, where we can directly make a point that similar elements might be also in Iceland, might be everywhere where you go maybe after the studies. Then again, shortly, the bachelor and master thesis topics, what would be the content roughly, and the ideas of the community that is behind that, with the PhD retreats we do and so on. A short appetizer for me, especially for some of you that have been not in the cloud computing course last year. The cloud computing course this year will have several overlaps. The technology is very similar. So when CPUs, GPUs, this aspect and on all the aspect of deep learning, artificial intelligence, machine learning, the things we learned will be reflected in the cloud computing course, of course, then put into perspective of hyperscalers like AWS, MS Azure, Google Cloud Platform versus rather our HPC systems we have here today. and also reflect a bit what's the cloud situation in Iceland, so Borealis data centers at North and so on. So the course we will discuss will be having also different facets, but there is some overlap, so maybe quite interesting for you. And finally, some job descriptions where I said we can go a little bit, let's say, go through LinkedIn jobs with some of the buzzwords you learned here in the course, and also reflect on the AI factory news. So let me start with high performance computing from another perspective. So this is really now, again, coming back after a whole course, what will remain, right? What would be now elements where you have three different facets usually, theory, techniques, and paradigms in a course, where you would say these are things that probably remain, whatever the details would be in the implementation. And that's why, the idea of a university course should be always looking a little bit like this, not what are short-term hypes, but what will be remain. And I think the theory that we have all around parallel algorithms that you learned in the beginning of the course, so chopping a big problem into smaller problems, is a paradigm and a theoretical element which will never be, vanishing. That is something which is even teamwork and so on. That. So these aspects of it included lots of theoretical aspects, much more than I actually was teaching. The speed up element, where we said, okay, it's nice to add more and more cores, more and more GPUs to really get, speed up, and we can, train AI models faster. We can do, numerical simulations much better. But you have seen also limits in the theory, right? So for the approaches, we had the idea of weak scaling and strong scaling. Strong scaling was putting more and more computing capacity. Weak scaling was doing the same, but also increasing the workload. Right. And there we will see that communication overheads will suddenly come, right? And having a problem of really getting, let's say, parallelization towards the end, because even if you have, let's say, unlimited computing power, the problem will be remaining in different parts. And this is also reflecting basically in Amdahl's and Gustafson's law. When you come to theory, Amdahl's law is the problem is the serial limits, right? There will be always some serial when you have communication from A to B. And you need to do this from A to B. There's no way to parallelize this communication overheads, but also data, right? Loading data in, preparing the MPI environment for parallel execution. This is all something where there are serial limits which will remain and that you cannot parallelize. So there will be always limits the more you go up. And Gustafson law is a similar aspect when you come to the weak scaling idea. So in a sense, we have the limit sometimes that we need to have much better simulations, put more problems to it. But this is easier said than done. We need the data. You have seen this in some of the CFD elements with screws, LSTMs from Razor. You need maybe much, much more time series data that we have access to. So we could scale up, but we don't have the data, for instance. So there are different elements in this which should be considered. Then the idea of numerical approximation, we had a little bit. So the theory says we can hardly have the real world simulated, right? So even the weather forecast in the end is driven by partial difference equations, numerical methods to, basically get the weather as close as possible, 3 days. And then the numerical instability comes into place. You know that all from basically Weatherstone, from our weather forecast. Everything after 3 days is probably very hard. Still, when you think about climate simulations governing similar aspects, not in that detail, can still predict something over several years. But it's an abstraction process, and by large, I think this approximation, which is important. On the other hand, then with deep learning, machine learning, artificial intelligence, you have something we call the statistical learning theory, which is very important. And I could just put very basic steps here in our lecture. So when you want to do machine learning, deep learning, you have to learn more about statistical learning theory. And this has relationships of why can we learn from data, which is essentially not really possible. It's only possible in a probabilistic approximate sense. We call this POC learning. So this is a huge element in it, that we're not doing a function approximation, but rather function approximation over distribution of data. So the elements which, machine learning from data have lots of theoretical limits. And that's why the statistical learning theory is very important. Also showing you the evidence of basically why we need validation, cross-validation, why we need regularization. So there are sort of elements which really are key to the heart to really learn well from data, which is an important part, including the famous aspect of, rubbish data in, rubbish data out. So there's lots of things which still need to be learned. However, I think as a basic crash course in a couple of lectures we had here, you got the story that HPC is really a key ingredient today to make it fast if you want to do deep learning and so on. From the techniques then for communication, the message passing interface is very old and still on vogue. So you have seen in some of the parallel deep learning frameworks, MPI is still the message of choice. So the interconnect working between different GPUs, between different HPC racks, this is a message passing interface. Then OpenMP, the idea of shared memory, will also not really quickly go away because we have memory hierarchies. We have extremely high speed memory where we can read and write data to. So also this concept is remaining and has limits, as you have seen. So hence we can only do OpenMP shared memory to a certain scale of the memory. And even if we would say we have, kind of need for more, we have seen it's very expensive to have memory. If you look into the new NVIDIA GPUs, Blackwell, and the other generations we had before, you see also an increasingly importance on the data with HBM, high bandwidth memory. Same concept fueling the GPU with data, right? Hence the memory, the idea of shared memory is an important part, but will have always limits. Hence we need distributed memory, message passing in the end. With doing this across different racks, the importance of going high performance computing means always network communication, no matter where. So in this sense, this is an important factor. We didn't have that much in the course. It's sort of the underlying assumption that the racks are all very well interconnected. You remember one of my videos, I think I showed you, was a second floor. Under all these different racks, there are lots of cables interconnecting all these different racks. So it's not just a laptop put next to a laptop, next to a laptop, connecting them a little bit with Ethernet cable. That's not what high performance computing is. Then when you think about the techniques to breaking down, a problem into different pieces, we call that sometimes meshes. Some things were in CFD, but also in other areas. We have this idea of discretize an area. So really, if we have the ocean, if you remember, we had the Cartesian communicator, have a Cartesian grid over the reality is a bit strange, but it captures the essence of what you want to compute, and you can always refine the mesh, make it, smaller in terms of kilometers. It covers. There are different approaches. There's even adaptive mesh refinements. We have seen that with the smoke evolving in a tube as an example in one of the lectures. So all of these ideas that high performance lifts from the idea of crunching things down into smaller pieces in parallel algorithms, computing parallel, requires us also to think about the domain as a technique, how I do the discretization, how I do a mesh, or even if it's block, we have seen the lattice as well. So different ideas how you can do this. Then machine deep learning is an interesting technique because you think about that many of the things we started with were governed by physics, so physical formulas, then using numerical methods, for instance, weather forecasts and so on. And also CFD is often doing similar elements. Machine learning changes a bit and deep learning the picture that learning from data instead. So you don't have the physics governing, you have data sets you start from. Also technique which will not vanish because we accumulate data every day. We have it everywhere in basically silos. The problem that we maybe face in the future is to bring the silos together to learn better from data. There are aspects like federated learning we didn't teach in the course which make that happen. But the whole approach is a bit a different technique, right? Which requires us then go back to the statistical learning theory. What if I defined a data where I have the same input, different outputs? You remember the Netflix example, you look the movie at once and you rate it like this. You look the same movie 1 year later and you rate it anotherwise. So this is something what functions and mathematics can't handle, right? A function wouldn't be a function like this. Hence, the whole idea is probabilistically looking at this and approximate then where we can go with this whole idea of deep learning and machine learning. Still, you have seen deep learning has some advantages with machine learning of the MNIST, let's say, simple data set as an example. And similar elements we see, of course, really in production examples. Deep learning by now has surpassed many of the computer vision algorithms and basic machine learning algorithms, and is a method of choice today wherever you go in languages, transformers, and so on. Then, of course, for techniques, computational fluid dynamics was a special in the course, based also on some of our industry requirements that have asked for us to do this. So this is a complete different area. of physics. However, we have seen, interestingly enough, and that's what we want to bring across, that CFD can be now intertwined with AI, with machine learning, with deep learning. This brings up a whole field we didn't cover of physics-constrained machine learning or physics-inspired, physics-informed deep learning. There are different words for it, but the point is to not neglect physics when you learn from data. So you need both is the future, and I think many appreciate this. And in this sense, this would be also an interesting field to study. It's still a matter of active research, how you really do that properly. We had a CU race that was working on it, but there's also more to come. And then for the paradigms, which maybe then stand for an even longer period of time, we have seen high performance computing in this course and contrasted it a bit with high throughput computing in terms of the interconnect. So in high performance computing, we have really a requirement, talking a lot, message exchanges a lot between the different racks, between the different nodes. High throughput computing is something what we rather have in the cloud computing course, breaking a problem into smaller pieces. Let's say analyze how many buzzwords are in different articles, news articles. Then you count them separately. You can scale that up to 10, 20, 100, doing this separately. And in the end, you have just summary statistics saying, well, this word was appearing in these news articles like this and this. There's no need for communication in between. When you do weather forecast, every single iterative time step, you need to exchange the variables. If you have water over the ocean, the wave height on your tile to the left will actually inform your own tile, how the weight is, and the next time the one right to you. So basically, you see lots of interconnection aspects in the high performance computing. And then the computational modeling is a discipline reaching to a very long, let's say, decades of engineering, building a bridge and so on. Building today whole cities based on airflow through them. We call that partly smart cities and approaches where you have lots of sensors helping you in the computational modeling to have better cities on a really high scale, where then high performance computing comes in. So how matter the scale is, you can go into the very few, right, small atoms perspective inside the human body and do their computational modeling. So this is a paradigm which is also stand the test of time, including iterative numerical simulations, speaking of the approximations, how you do this, and also the learning from data and artificial intelligence is something where this has been done way in the past before computing was really there in high performance computing. And the learning from data paradigm is something which will prevail no matter what we have in artificial intelligence. I put here AI particularly because it's larger than machine learning and deep learning. So general intelligence. So are we now going to, more human intelligence than just the machine and deep learning algorithms? So this is also a paradigm which will not change, which have been basically researched. And many of the aspects, whether you go to, modeling of physical phenomena, or you go to deep learning, machine learning, hyperparameter optimization will be important factor. The parameters that, let's say, govern a model are very important. And also then deciding which model to use, which is a little bit the AutoML that you also learned in one of the course hours, are very important to see which artificial neural network at all is maybe the best one for a given problem. So these are all topics which will stand the test of time when you go out here, and chances are in 10 years we will talk, still much about it. When you want to read more about it, of course, obviously today we have a big internet. So, there's lots of material around it. One of the training materials I would, let's say, encourage you to read is our EuroCC Access Training Network. The competence centers, many of you have been in our Icelandic HPC workshops, which are organized by the National Competence Center of Iceland. But you see here, we have a large network across Europe. I was also presenting this in one of the lectures, right? And they all give training on different aspects, on different tools, on MPI, but then not one course for 40 minutes or 2 times 40 minutes. It's a whole week. It's 3 days. So this is where you really learn the substance to get more into the game, as well with OpenMP, with artificial learning. You have the link here to the training portal, and there you can also search and see what basically trainings are available. A couple of them are here basically available. And then, of course, I gave training in the past. So the YouTube channel by now, We always change the course a little bit. Some lectures go in, some go out. We update the material. And if you go back now in the YouTube trainings, you basically see, here and there some changes. A couple of years ago, we didn't have a CFD special, for instance, so there would be much more different, let's say, applications in science and engineering and physics, which might be interesting for you to look at, and with different, let's say, insights into, where you can see HPC is used. I also wanted to take the opportunity because we were exploring in this course quite a unique aspect. So we tried for the first time to have a final project alongside the course. So I'm also interested to see how the students were seeing it to get rid of the exam, but of course having more load over the whole duration, if that's really a good thing or not. We basically did this on your request. So to turn the exam into a project, we turned it into a final project in a cloud course, but this was a bit too stressful at the end. So we thought doing it parallel during the course would be good. We sacrificed some course hours for this. In this sense, the short lectures were a bit more this time, but that was not necessarily a problem. So far, we got reflections basically from our industrial partners. So, but I also interested, alongside with all other instructors here, to see how you thought about this. So basically, is that something what we should continue, or should we go back to exams, or should we go to final projects? Now, talk about final projects. Many of you have been involved with some SMEs. And just to show you that basically on a larger scale, when you continue to do this maybe in industry later and want to be inspired, what can you actually do with industry in HPC? There's again the website here on the EuroCC2 network, which has lots of success stories collected. We have also contributed to with SME Greenfish and SME Treble here from Iceland. So where you see where we do HPC in Iceland with them. But here you see, of course, across Europe, where basically industry is using HPC. And chances are, if you as a student work in a different industry after you're studying, chances are that they already use HPC, but you don't know that, but you can check where other people in this industry use HPC. So it might be also an interesting facet, for you to understand in your own company. Can you leverage HPC? Needless to say that many of those are now also talk about artificial intelligence. You see here one good example, LLM fine-tuning, right? So large language models, big domain in industry. We almost daily talk about it in the National Competence Center. Just this morning again with EDH and so on. And you see again an LLM example here. But then also, speech to text related aspects and so on. Hence, I would encourage you to look at this website, just to browse through. There are many more where you can see a little bit of, where actually HPC is used successfully in industry and in SMEs. Then also many of you have been already participating in our EHPC workshops, so thank you very much for attending. And you're, of course, further invited. This would have maybe not an impact into your points for some final project, but you're definitely invited to join us, for instance, in the next one in August. We don't do one in June. It's a summer break. So usually we have just essentially then one in August, October, December. And the website ehpc.is. Please register for it. It would be nice so that the catering is right, that we don't run out of cheese and wine, as you know, and also catering. But if you let us know, that would be nice. If not, it's not a big deal. Bring your friends. And we have to thankfully here, quote also that we get funded by the European projects here to make that happen. Hence, you're part of the community now. You have seen HPC, you have been participant of the HPC community workshops. Feel free to continue working with us. Just here, a key pointer also to our expertise, the 12 simulation data labs. So this might be something where you can become involved in the future when you do, your future work in industry, leaving here the master and bachelor programs. We also do this in collaboration with industry. So don't, be shy, come back to us, talk to us, say, well, we are now in this company, we are thinking about HPC adoption or AI. Can you help us? We have basically lots of programs here in Iceland, like EDH, the European Digital Innovation Hub, being a one-stop shop for AI to really help industry to get you going. And as you know already some details here from the course, I think you can really also maybe convince some of your bosses or your senior engineers, as it is called sometimes in the companies, to maybe make the move. Here again, some examples how you could use it. How many people work in several simulation data labs is more statistical information. The same is actually true for public administration. You see an avalanche, basically in Flattery from the Met office here, which was created in open forum, CFD. You got the story, basically, you have learned the basics. Of course, now applying it to a real situation in Flattery for avalanches, it needs more work, right? It's not that a HPC course can easily tackle this, but you have the basics and you know how to approach the problem. Still, you can also talk to the National Competence Center and get help in doing so. Then the large aspect of large language models, natural language processing. We have a TrustLM European project here, me together with Hafstein, but we are all here involved from my team, where more will happen. So especially with the Icelandic corpora, we work with this intensively. And there's also chances that maybe your company is interested in it, maybe for downstream tasks, so language translation or chat box in a company or so that is understanding Icelandic. So this is just an example where we work also with industry like SME Methane, where we have no problem also working with other industry collaborators if you go there. Then collaboration activities beyond that, if you go to Europe somewhere else, to your other countries you basically come from maybe, there are lots of collaboration opportunities. There are lots of large industries around, data centers around. The EuroHPC JU is basically very European. I come to this also with AI factories, which are now a new thing and a brilliant opportunity for all of you getting jobs, because everybody is searching now for people, fueling the AI factories with people and having the expertise you learned in this course. So good chance. So also maybe look at the Icelandic website from EHPC again with an idea, how can you do an international collaboration? We have lots of links, as you know, to different membership countries of the EU and so on. And we can also help you even across this. Our community is stretched across America, China, basically very international these days. If you really want to do low-level HPC, there's one book I would recommend, which is also sort of stand the test of time, is very good written from one of my colleagues from the HPC community. But I think also these days you have lots of material outside, so I would not necessarily maybe buy it, but if you're really interested, then you can really have OpenMP and shared memory aspects understood to the very heart. Briefly about bachelor and master PhD thesis topics, what would be, of course, a quintessence. So if it's interesting for you to work in the topics we had sort of in the course, right, which are here basically think about several methods and tools related to statistics, machine learning, scientific computing, data mining, parallelization. So this is something where we have lots of topics available. You would be something in between, you would say software engineer, statistician, engineer, data miner, something we call sometimes a computational scientist or data scientist these days, right? Where you basically combine the areas of different fields together to build something in applications, which is an important factor, and hopefully get some insights which are swimming there in the ocean. And yeah, master's theses are very easy. For the PhD, we have to talk longer, but also PhD is quite fruitful. I mean, Reza was once a PhD here with me, so you have seen him in action as a postdoc. So I'm very grateful that he also stayed basically after his PhD. And I think an important part is also to understand that you're not alone as a PhD here. We have always this retreats here over the last couple of years, and we have also one again in this fall, where we bring all the PhDs always in a community together, so you're not isolated and rather work together as a team in the research group. So if you're interested, let me know, or let one of the instructors know. I mean, Heyman also and Reza, they can be that's our first contact for you for this. A sneak preview, what's happening to the cloud computing course in the fall. Again, I was saying, I mean, you can look in YouTube what you would expect. I record everything on YouTube. There will be some changes. Definitely as a European sovereign cloud, there's several different facets so that you always have some elements of change. But again, we talked there about some paradigms, MapReduce. I mean, have you heard about MapReduce maybe? Not really, not Hadoop, MapReduce, some of this Spark, Apache Spark. So there are more, let's say, different frameworks that we will cover in the cloud computing course, which are more, let's say, adopted in hyperscalers like Azure, Amazon, Google. But if you go under the hood, you will see that the deep learning algorithms, machine learning algorithms don't change very much. That the provisioning of GPUs is also not changing very much, right? It's much more a commercial way how you get basically access to these resources. And maybe here and there's this service paradigm, right? Everything is a bit more simpler to use and so on. So this is what we want to understand there. Also, what fuels the system, like, big, large user groups. We'll talk about Facebook, how they use it, but also enterprise resource planning and other, let's say, applications, combined also, of course, with a huge, let's say, view on big data, machine learning, deep learning, again, how you can use these systems with this. So here goes a sneak preview. And then maybe towards the end, let us just acknowledge, first, Reza for the CFD part. Thank you very much. It was very kind to take the CFD part here from Reza. And Christian, you're just here. I have you on the acknowledgement slide. Don't run away. So you need one of my senior scientists here, Christian, Helmut, Matthias, Oliver, that all helped me with the management and organization, of course, stuff and around it. We have also basically the team that gave you earlier and Jotun partition access. Sigurd Detlef here, this guy, I know you don't really have seen him maybe, but he is behind your accounts, as well as Elva working on Jotun and Ertla to make it happening. I apologize on this, that actually exactly in our HPC course timeline, they transitioned the system from our location at HOE to the Met office. So there were some interrupt, especially towards the deadline. So that is what we then, let's say, mitigated by dropping assignment 3, right, to get you more time now. And this should be hopefully a fair deal. And then, of course, there are more machine learners here I would encourage you to talk to. Some of you maybe took already Stain's course in the past, but also Hafstein is a great scientist and teacher for large language models, natural language processing. He would be the guy to talk to. And then Thomas Philipp, optimization, operations research, machine learning, deep learning. He's also a good guy to talk to. There's a possibility to look at the cluster. So we either go to the Borealis data center again, like in the last years, or we go basically to the new location Met office. We have to find out. But let me know and send me an email, then we can organize a trip there. We will probably collect a couple of students. In former times, we did this within the semester, but usually at the end of semester, everybody's very busy with exams, with assignments, final projects. So we thought we're doing this after this period, right? So we find a way. The data centers are all day around operating, so there's no point of doing this also towards the end of the course where everybody is very, let's say, stressed anyway. For job descriptions, this could be taking, let's say, hours. Obviously, I think two that are quite known is, for instance, I think LinkedIn jobs, right? This is something where you have a direct access. If some of you are not in LinkedIn, I would recommend you to do so. It's a professional platform, not just a little bit of social media like Facebook or something. It's really a professional platform these days, where if you are in the business sector and moving from student to, let's say, a really employee, this is really a step that you should consider. I'm not paid by LinkedIn, by the way. I just say this has opened up lots of opportunities, I think, for everyone. And it has a job part here, where you can maybe search. I just search for artificial intelligence and get lots of different jobs. And if you then sometimes go in the detailed description of the job, you will find again AI elements, ChatGPT, head of AI. So you have to understand a bit of AI features. So you basically several things that you already learned in the course. And you see also why maybe the cloud course is quite complementary. Everything that I just gave you as a sneak preview. AWS hyperscaler, Google Cloud, MS Azure, Docker, a container technology. We didn't talk about this in the HPC course. We talk about this in the cloud course. So hence you see for the job description perspective, if you want to, let's see, be a master to really apply, I would also recommend you to look at the cloud computing course a little bit. If you want, there's lots of complementary aspects that really gets you to an expert. And if you go further, you can browse through that yourself. I don't want to take too much points for it, but you see quite a momentum on this NLP, large language models, as I was alluding to. This will probably stay with us in the future a bit. And you can, go through different facets, maybe also just briefly mentioning Glassdoor might be another idea where you can find jobs. I put just deep learning in to have something different from artificial intelligence, machine learning data scientists. And also if you here go through the different, let's say, details, you will find machine learning models, you will find different elements, TensorFlow, something you already learned in your assignment that you had already on the slide, which basically is related to, good jobs. Again, complementary would be Azure, Spark, things we talk about in the cloud course, right? So hence, it might be useful for some of you who are seriously interested to be a machine learning data scientist somewhere. I mean, think about the salary, it's not so bad, right? 100,000 plus 140,000 a year. But of course, then you have like many of the things, maybe PyTorch, TensorFlow, you know already, but there are several other aspects, data collection, SQL, that we have a little bit more than in the cloud course again. Yeah, you see also one of the things I mentioned, physics-informed machine learning specialists. We were alluding to this, right? To combine these two worlds. And you see there will be jobs open, etc. So let's see a little bit what's coming up for you. And this will be really why my last sort of slide of content is now the idea of the AI continent. I'm not sure, have you seen that somehow? AI continent, AI factories, the plenum here in the, I should also ask the online audience, sorry for that. I hope some of you have actually seen that in the news. But this is a new big plan in the European Commission that, basically we will be, or we try to be, let's say, AI leading in the world, of having lots of different investments. You see here 200 billion euro go into this. Lots of jobs will be created in the next 5 years to 10 years. And one of the key aspects of HPC will be these AI factories, which have been already developed. So there are 13 around that are basically operating right now, where you with your company can get access right now, right? So these are your HPC supercomputers, especially for AI designed, which you can use. And we are part of this ecosystem. So when you go to the Your HPC website, you will also see lots of ideas how to apply for an AI factory and so on. So in a sense, it's HPC very optimized for AI. And the point is now, you see here all the new AI factories, they search heavily people. It's not just hardware. Important is also that you have software, services, people catering, basically the needs of the people using it. So chances are that you find alongside these factories also job openings in all these different member states. And with this, I close here. Basically, I give you this video as a homework, AI factories. If you go to the European Commission space on AI continent, which is a larger action plan with 5 different pillars, if you want, then you find much, much more information, right? But of course, the ones that is very relevant to HPC are the AI factories. We will develop gigafactories in the future with, let's say, billions of euros of investments together with industry. And I leave it here basically for you to look at this. And I would say we do a small break before we do to the Q&A. My final statement is, of course, thank you very much for being part of the course, right? If you don't have any questions and want to leave, thank you very much. It was a great pleasure to do this course, especially as we're exploring a little bit more close, let's say, work with industry. So again, in the Q&A session, I would like to love to have your feedback on this. So thank you very much also for the online audience and YouTube giving all those brilliant comments and very nice comments. I'm also very happy about this. I could use that in many reviews. Thank you very much. And of course, we take also your feedback into account if there's some changes, and the slides will be all publicly available as well. Thank you very much, and talk to you or see you soon in some of the community events.